Okay, we are actually live right now. Okay. So, as the title created, gitu ya, uh, we are actually going to have to make KMeans clustering algorithm using Golang from scratch. And yeah, we are attempting to create Golang from scratch, and just like another life of me. It will be a multi-language. It will be a multi-language streams. Second, wait for a second. Okay, it will between English and Indonesian. So yeah, expect me to do well is something that you actually overdone. Now I have to adjust my volume a bit. Okay. So it doesn't get to the red bar. Is it great? Yes, it is. Okay. So first of all, we have to uh, select the folder itself, open folder, and you can see that I'm now in the source path right now. So what I do is I'm going to go to my path and to my repository. So this is it. Go KMeans. Why I'm using Go? Well, because I can. It's because I can, and so yeah. First of all, what I want is a main package. So yeah, expect like go main.go, create the main package of this package main. It's not import anything, just like import uh empty, and we could just like function main. And what I it's been a while since I'm actually using this language, like Go language. So I think it's fmt.println hello world, and we can actually do the tabs, but why the hell it's not? Okay, and the tab is broken. I don't know what it happened, but yeah. Okay, a simple hello world, and what I do is I'm going to go to my path, and you can see what my screen is. It's okay, I think so. So you guys cannot see my path also. And users go source github.com camel5p go KMeans, go all out like this. Oh, it doesn't matter actually, but yeah, it's just a convenient thing to do. And let me see, let's go to window capture my CMD. Yep, just create this. Nothing special, nothing really special. Yep, and we go run our main.go. It's hello world, so it's okay. It is all okay. Up until now, it's all okay. All right then. And we going back to the main.go. If you're in hello world, it's okay. So for the package itself, I want to see. Hmm. how do I import things? How do I import things in Go? Okay, how do I import things in Go? Hmm, let's see. Can go to our Opera actually. Can go to our Opera. Yes, I just searched for it. Where's the Opera that we are asking? Golang. Go import CSV. We're going to Stack Overflow. Let's see here. Encoding CSV, reading CSV files, and into a string, multi-string, and okay, it's read CSV files, and we need all of this. We don't need all of that actually, but it's really convenient if you have those things. Okay, coding CSV is will be R. No, we want it local, and the records just like this. Save it. Going to the here I will import no. I will import the data sets for a minute. Kendaraan. No. It will be CSV files. As you can see there. It is a CSV files and able to cover. You know what? I just like copy paste it. Now, what I want is can you daraan underscore test. Can you actually read this? Let's see. There's the main. Nope, the system cannot find the file specified. Alright. Okay, let's see. Just like this. My Droid Cam is low battery. Oh, it's okay. I'm using Droid Cam actually. And let's see again. Let's run it again, and the system can. How about like this? System unable to read input file. CSV open. .csv. Okay, that's the problem. That's the problem. Okay. Now go back to the Opera. Let's go back to the Opera and let's go encoding CSV. We need to read, able to parse, and able to read input file. And yeah, the error is the system cannot find the file specified. Able to read input, the system cannot file specified. And let's go. Golang. Okay, if I let go the cs.csv files, is it changing anything? save it first and go. Nope. Still not opening actually. Unable to read input files. Slash data underscore test. .csv open. Wait a minute. With CSV file open the path. Let's only see what the problem is. Is it like the error? Or should I have like okay hub.com/. That was my path. That is my path. And let's see how it went. Cannot read. It's really actually tricky. He cannot read from the source. Golang cannot read. Files. Code main declaration. Check if it's error or not. Index HTTP. Okay, it's backend stuff. IoT read file. Oh, you know what? Let's make a dataset. Let's make a dataset from it. Okay, let's make it. So we comment it out. We have hello world. Comment it out, and then we are like use no. It's a global variable, so string it is. Datasets, mini dataset. Oh, just like datasets. String var datasets. String. But I'm using this. Is it okay? I don't really know actually. I don't really know actually. Is it okay or not? Oh. How do I declare string in Golang? It's no. Array in Golang. I'm actually searching for this. Length for index element, blah blah blah. to go. So we have to assign it first. Let's do this. Okay. It will be two-dimensional. Rows and column. I will have, for example, 5 column. Let's do an iris. Iris dataset. Mm, 1, 2, 3, 4. We have 4. And about, let's see. There will be 5 actually. It's sepal width, and petal length and petal width. We have like 100, just 100. Yes, 100 records, so it will be 100 string. And for it, and yeah. Okay. We have 4. Okay. No. Actually, yeah, this is progress that I want. Using this, for example, the first row is 7, 3.2, 4, 4.7, 1.4, and it will be float 64 and 100. I don't know, just roughly like this. Okay, let's have yeah, 5 more. Why not? It's 6.4, 6.9, 9, 5.5, 6.5, and 5.7. For all the width is 3.2, 3.2, 3.1, 2.3, 2.8, 3.3. Nope, it's not 3.2, 3.0, 3.1, 2.3, 2.8, 2.8. Okay, and the pedal rank is 4.7, 4.5, 4.9. No, it's 9. 4.4, 4.0, 4.6, and 4.5. So it's 1.4, 1.5, 1.5, 1.3, 1.5, 1.3. Okay, this is our data sets, I think. So mini data set is just 5 data sets, and yeah, it's not too good for a data set. It's just like an array or something. It's an array of a float. So yeah, and then we make another files. Before we making our new files, what I want, uh, this is a main package, so we have to import things to go KMeans.go. Oh, this is not a folder. I want this to be a file. Go. Oopsie. Delete it. I want this to be a file. Go. What time is it? It's 14:44. Go KMeans.go. Says package. Go KMeans. Save it. This error is just like this. I think it's okay. I think so. So what do we have to do? So what do we have to do with KMeans? What I want to do is the Kmin itself. So struct of type Kmeans struct. It's actually a centroid. We need a centroid. So type coordinate struct. Type will be float 64. It will be x y. What I want is two-dimensional clustering. So it's x and y. It will be float 64. What else? What else? What else? That's it. I think that's it. Now, KMeans, we need centroids. So centroids. Now the centroids will be a coordinate. Now, because the centroids is a coordinate, what we need is fitting. So fit. So we have a centroids. Okay, KMeans have a centroid for it. And KMeans struct and will be function just for K and KMeans. We want this to learn things, so we have to fit. And what the result of the fit? The result of the fit is actually the data sets. So what we have to do, the data set, yeah, well, the array of float 64. We don't care what the amount of array is, but we need an array. And what we need Well, it's optional, but we could have coordinate. Hmm. We might have a scores, but that is not necessary. For a while, we return null. I don't know why the tabs is not working in this time. Well, okay. So fit can return our center rights. Okay. So what we have to do, we have to go back to the drawing board actually. What we need to do, there's a lot of data. Okay. There will be a lot of data in here. It will be making a grid. So we want to make a random centroids first from the data itself, or we can choose one data for centroids. I think randomize it. It will be great idea. So let's see. Let's have a randomizer. Uh, let's import. Actually, let's import math.random / random. I mean, and I don't know why the tabs are like buggy as fucks, but you know, sometimes things happens. We want a random centroids first. So what we need to do is create the centroids, which means randomize it. So function KMeans struct, we need how many k. So it's KMeans clustering in how many k, and k will be integer, or n cluster, n underscore cluster. Big boys centroids. Array of centroids. And cluster. Yeah, I think it's okay. Okay. And cluster and centroids. So what we need to do is using the KMeans to initialize centroids. Actually, we need this. We need this. Oh, we're choosing the random actually. Run. Okay. Random x is a random n of the length of array. The random y, x, y, and length of array 0. From that, we now have random numbers. Now, what we need to assign it. Okay, so centroid is a centroid. Oh no. Coordinate using r x no it's not. Okay, point. Is a point where the x is r no. So the y is the row, the x will be the row, the y will be the row, the x will be the column, right? So yeah, the axis will be the column. But that's in mind. So there will be 70321. I want this to be the centroids. 4.9 to be the centroids. But the thing is, what is 4.9? 4.9, for example, we just use these two pedals. Okay, it's this two column. Okay, it's just two. What if we just did two? So we have a two-dimensional column. This will be the coordinates, right? This will be the coordinates. So the x, it's y. How much? So we're choosing the random row actually. We are using the random row. Which row that we are going to use? For example, we're using this. So the point here, the points we're using these coordinates for the centroids. So what we could actually do is just like this. Row 0 and y is our, it's just like a face form of the year from me actually. Simple as that. Okay, and we return it. So what does the k means to? Oh, okay. We return. I know. Okay. What we need to do, then go and see. Let's do this. Okay, what we need to do actually, have a loop over it for e0 e less than k dot n cluster e plus plus I plus plus. Okay, and just like this, we need sense. Sensor for sense, it will be an array of centroids, array of point, and sense equals append sense chen. And where does the chen is here. So we returning the chens. For that, you can go points. That for initialize the centroids. Now, so it's somewhat like constructor. Is there any struct constructor in Golang? Because it's not class thing. Okay, so I have to create the k-means first. Okay then k-means fit, and yeah, it's all right then. Fit, after we create, we have to clustering all the data. So what we need to do, we need to have KMeans. We have to predict or we can do this. Yeah, we can do predict and so predicting. So what we have to do actually, what we are going to do. All the data in an array, all the rows are calculated with the chance. And the chance is in here. Here in it class centroids, it will be centroids. So predict will be hmm, mm, oh no, think. We calculate the distance between, okay, the one point to the other. So for I0 I less than the length of the R. Why the music stop? Why the music stops? uh, so we iterate all of this, all of those data, and we calculate with Shan. We have what the minimum size of the Chan is. So we calculate it with using Euclidean. So we have to make Euclidean distance. Between two floating arrays. So in an array, float 64 between a point. P1 and P2, and this will be coordinate. Oh, this will be a point. 64. Okay. What is the Euclidean formula? Euclidean formula. Euclidean formula. Formula. Okay. So the Euclidean formula is like this. This minus the coordinates P1. It's like this, and we copy this, and we go into here. Okay, it's clear. So what we have to do is calculate each dose. Okay, what is Golang power and math.pow? square root. SQRT using math. We are using math. Okay, math. What is total? What is X? Is P10 minus P82 dot X, and we power it math dot pow. Power of 2. Okay, Euclidean distance. Hmm. Now, predict. We have to predict. Each point will be predicted. Okay. Each point. So we have to define the minimum, the closest one, closest. Let's set it to 0. And for J, hmm, uh, for each loop, I want like I would like this. Will be the content. So the data in range of R, closest one is 0. So in J, data is K dot centroids. Next, and mk.central is 0. With the chan slash then the file min, then file min will be distance test with the distance and idx j. Okay, after that we have actually we need var level cluster integer. So what we need to do is return the cluster, and we are included cluster pen dx underscore min. Okay, which one the closest one, right? Okay, pen cluster dx minimal. That was the predict, and we sum it up. We mean it with can I do this? And I was wrong. We don't need it. What we need is the phone. We want it clustered, so um, cluster data. Again, it's experimental. How long did I stream actually? I want to see. I don't know, but keep in mind 15 for for E5, I think. I have to check my school. LMS. Because I think I have a class right now. Not right now, but like couple minutes prior. Okay. There will be a post test. 10 November. What? Okay, it's alright. There's no post test or everything like that. Cluster data. Now, this is a tricky part. We have to convert the array of load to point. Hmm. So what we need to do is convert all for um, EI in the C range of cluster. Yes. We also creating how much the K? No, it's just like this. What I'm thinking. K dot and plus construction. Cluster data. Yeah. Can I do this? It must be constant. So for a cheeky way actually, but yeah. No, it's an array of an array. Ah, okay. Just like this. It's done. No, just for the cluster data. Oh shit. In each clusters, we know each cluster is. So what we need to do is again using the I and the array. Yes, we need a point. P data is a point. Where the X is our I and 0, and the Y is our I and 1. Okay, that's P underscore data. We convert the data to the point. After that, we have to go to assign it. Oh, okay. Cluster data C equals cluster data equals append cluster data C underscore data. What the hell did I? Why the hell did I start? I don't know, but that's it. So it's clustered, and then so what we need to do is actually man the calculate the average of each clusters. So for each cluster data, we need to do for each cluster data, we need to calculate it, calculate all of it for J and C. So it's different C with the one in the 60th line. And the cluster data range cluster data. Total underscore X is 0. Total underscore Y is also 0. X C dot X should be good. Total underscore Y length of the cluster data, length of the CD itself. Okay. That was the main cluster. Just the predict. Fit float 64 plap. First of all, we need to write it first. Hmm, plus going to the 4. Okay, the predict. No, centroids. We need comparator function. Compare point. CP1 point, P1 point, P2 point. So if it's not equal, it's still looping. So not compare. Okay, dot centroids. Oh yes. Okay, I think it's safe because yeah, to then predict main clusters, what we need to do. I think that's it. Do we need one 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. That is 6. Let's actually do it, I think. Yeah, I think print the dataset first, then we import. Okay, let's go. Hmm. But it's 1542. We don't have time to test it, and yeah, I think it's just like this. For the main itself, I want to actually fiddle it out, compare it. But yeah, I think that's it. Thank you for watching. If there is anyone watching, so